Hi, I am Vikas. So today we will be doing about foundation design. So this is our last problem where we have done. So from this e-types I have taken the values of the loads and dead loads, live load and the plan. So these are the values I have taken. So this is the plan where I have taken. So where I have taken self bearing capacity 300 and alloy wheeling set 1 centimeter, and so these are the values for column 1, column 2 up to column 16 columns where I have taken dead load, live load and the dimension. So these are the column 9 to 16. So now we will do a design. So this is the software using safe software. So we will design the foundation. So click on the file, new model, design code as Indian IS 456. So design preference where we will modify. So minimum cover we will give 50 on both. So we will use the preferred dia of 22 mm. Click on OK. So now units where we will use metric dip. Click on OK. So we will use a grid. So next, so there are 18 meter. So we will make as the 19 grids on the both direction, x and y direction. So each grid spacing will be 1 meter. So now we will define the material. To define the material, define material. So now we will define the material, add new material. So here we will first take as the M40. Material type concrete. So for the M40 weight per unit kilometer is 25 as you know, and the elastic value is 3106 22.7 and ratio is 0.2, where the coefficient of thermal expression is 0.55 and compound cube FCK value is 40 Newton per mm square. Click on OK. So now another material where it is HSYD 600 of rebar 77 models of 220 the power of 5 F 500 F5 then 45. Click on OK. So these two are the material defined. Click on OK. So now we need to define slab properties. Add new slab. So here we will make a slab as mat footing. Select as M40 and size of, we will give size of around 500. So after defining mat, so next we will define column. Add new property. So column, we will take two types of column, 500 and 600. So first we will define 500 and 500. So metal M40, size 500. Click on OK. Next add new property where column of 600, M as 600 and 600, metal type M40, change the dimension 600 into 600. Click on OK. So the two columns have been defined. So now soil, subgroup open soil, So soil 1 we can modify it. So where it is at 2e, so we will need to make it 3e as a given. Okay, so now we need to define load pattern. So there is a given dead load, live load, 1. Okay, click on OK. We need to check load case. So dead load linear, live load linear, click on OK. Define load combination. So in load combination there is no load combination, so we need to add the load. Add new load. So load combo 1 dead load, so our value is 1.5 for dead load combo 1, and here live load 1.5. so here the design is strength, click on OK. So add another load combo 2. So here select dead 1 scale factor, live 1. So leaving strength we need to select initial series, normal, long term, click on OK. So these two load combination are defined, click on OK. So after defining, now we need to draw the footing. First we need to draw a slab. So here we need to take a slab mat footing. Select the point. So there is a 18 meter, up to 18 meter, next up to 18 meter. So move back to the starting point and click on escape. So now we have defined the slab. So we need to provide an extra 2 meter on each side. So click on select. So they have selected one area, edit area. So we need to expand the area. So they have given mm, 2 meter means 2000 mm. Click on OK. So the area has been expanded. So the slab we have been provided. So now we need to draw a column. Draw column. So here we need to change the property. So property above we need to be none, and below it should be column 500 and 500. So height is 0 and height above is 2 meter. So now we need to draw. So as we need to see it 500. So there is a 6 meter each. So we have done fourth column. Now we need to draw fifth column. So here again on column drawing 7, it is a different size. So we need to leave out column 6 and 7 of different size. So as we can see in the question, so column 6, it is 600 into 600, 600 into 600. So we are leaving the column 6 and 7. Again in this also the column 10 and 11 are different size. So we need to leave. This is 9, column 9, column 10, column 11. And escape. Draw column. So now we need to change the column of 6. So the column size 6, column 6, 7, 10 and 11. So now we have drawn the column. So now we need to draw a design strips. Draw the design strips. So now has the column strip here, column strip. So width is need to change 4 meter. Width left right on every side is a 4 meter. We need to change. And now we need to draw. So now we need to change the strip layer B, draw in a y direction. So after drawing the strips, so now we need to assign support. Assign. Select. So here you can see that one area is selected. Assign support data, soil properties. So soil one property, click on OK. So the soil one property has been defined. So now we need to select. Now we need to provide a column loads. So on a column we need to provide a load. Select. So we need to see here that is one point selected. So assign load data, point load. So here dead load. So for C1 column we need to refer how much it is the dead load. So 1850 is dead load. So 1850 and dimension is 500 mm. 500 mm. Click on OK. After providing dead load, now we need to provide a live load. Click on and see that is a one point selected. Same. Assign load data, point load. Here dead load instead we need to select live load and the values we need to refer. For C1 live load is 797.6. 797.6. Same dimension 500. Click on OK. As like that we need to provide for up to column C16. So here we need to change the dimension. So we will leave the column 6, 7. So we will move to the column 8. Column 8 date load. So provide column 8 date load. Live load. Again here the column size of different size 600 into 600. So again we will leave these two columns and move on to the column number 12. So now we can see that we have provided dead load and live load. So leaving this because it has a different column size. So now we need to provide. So it's a column 6, whereas a column 6 has a different value, dead load of the value. So here we need to change the dimension. Okay. Sign data point load. So for a live load, it has a load of 2797.8. So here we can see that it has a 600 to 600. No need to change again. So it's a column 7 dead load. It has column 7 dead load. It has 4977.2 of size 600 into 600, and live load of 2579.8. So similar as a column 9, now it is a column 10 and 11. So now we have provided the load. Now we write escape. So after applying the load column, so we can check the load clicking on the right. So here you can see the load. So it is a column strip, yes, and so we can change the ribbon material. So on every material we can make it as changes. So we need to change for every material, so one by one. So after changing the load, now we need to change for slab also. So it has been changed. So for design strips, so we can see here the design strips. So there also we need to change. So here we can see that we are changing the strips which we have selected. So we can see that we have changed. So here we can see the dimension. Once again we need to change. So after applying the loads, so now we will the run the analysis. So before that we can save the file. So here we can see the values -9 to 4. So these are the displacements. So again run analysis and design. So now we can the punching design. So there are the values of more than one. So we need to reduce that. So to reduce that, unlock it first. After unlocking, so for the define slab properties, modify. So here we modify 1200. Okay, so run analysis design. So now you can see the punching shear value. So where we can see that it is the less than 1. Every value is less than 1. So it satisfies between the shear value, it satisfied. So here we need to exclude value. Click on OK. So it has excluded value. So now we can see that now we can see the 3D value. So display show strips forces. So we can check that. So we will check it like so. These are the values. So next we can for shear force also. So these are the shear force values, the diagram. So we can see that for layer A also. Even shear force you can also see. So these are the visible. So we can use the maximum moment. You can take a load combination. So we'll play combo 1. So these are the values which you can see. Change we can take combo 2. So these are the values you can refer. So now we can see the run detailing. So we need to select 3 and click on OK. So it has created details. So here we can see that reinforcement details, draw component weight, slab view, rebar table. So these are the table where we can see the values. And this is the rebar schedule. And this is the bill of quantities for bar size, and the length will be given and it is weighed in a ton. So this is the plan of rebar plan. So here we can see that bars, broad, longitudinal tabers. So this is the reinforcement profile. So this is a profile A. So this is the profile B. So this is the section. So we can see in the section 2 also. So this makes the complete, and it has been used because it is a safe, it is easier than any other app. Thank you.